Okay, here's unit 4 called triangle congruence. I also call this the proof unit, so we're going to do some proof stuff. Let's start off by hypothesis and conclusion. So anytime we start proofs, we start with what are called conditional statements. So you'll notice the hypothesis here, I'm going to underline or highlight in yellow. Hypothesis always follows the word if, and my conclusion always follows the word then. Okay, so just looking here, what's the hypothesis? You are an American citizen. Now, be careful when you pick this, because look at this says you are not American citizen. So there's some negation to this too. Okay, and I can tell right now. So the first one is B. There's my hypothesis. Okay, what is the conclusion? You have the right to vote. Boom. First one that pops up. Okay. All right. As I go through, question 2. Determine if the conditional statement is true or false. If it is false, find a counterexample. It says if an angle measures 80 degrees, then it is acute. So here's my hypothesis. If an angle measures 80 degrees, then does this have to be true? And I would say yes, an angle of 80 degrees has to be acute because the definition of acute is less than 90. If it was false, you would come up with a counterexample. Okay, so boom, the conditional is true. Okay, next problem. Question 3 here. Okay, if I'm in Oregon, then I am in the West. So here's my hypothesis. Always follows if. There's my conclusion. I am in the West. Okay, we also like to say the hypothesis is RP. And the conclusion is RQ. And conditional statements are if P, then Q. Okay, what is the converse? The converse means I'm going to flip-flop these. So I'm going to put the Q first, and then the P second. So I'm literally just flip-flopping these statements. So I want to start out with something about being in the West. And I like this one. If I'm in the West. If I'm in the West. I don't like this one because this says not in the West. This one talks about Oregon. No good. Okay, moving on. Then it's got to be the P. I am in Oregon. I like this one. Don't like this one because it says the word not in Oregon. Okay, so the correct answer here is A. Now, is this true? If I'm in the West, then I have to be in Oregon? No, we live in the West. We know you could be in Washington. That would be an example of a counterexample. It says determine the truth value of the converse. Okay? And obviously we know it's not true. Now, false and false. I can be in Oregon and not in the West. That's not true. I could be in California and still be the West. There's my counterexample. So I like this one. Okay, write the inverse of the conditional statement. Okay? Now the inverse is if I negate these. So I'm going to take my original one. If I am in Oregon, then I am in the West. And I want to negate these. So what's the opposite of being in Oregon? Not in Oregon. What's the opposite of being in the West? Not in the West. So I'm looking for the nots. So I like this one. If I am not in Oregon, ooh, and then I like this one. Then I am not in the West. So the inverse has to include the negation of whatever your statement is. Not and not. So I like B here. Determine the truth of this. If I'm not in Oregon, then I'm not in the West. Is that true? No, that is false. And I've got two false potential answers here. So let's look at their arguments. So is it this one or this one? It says if I'm not in Oregon, that means I could be in Washington, right? It says I can be in Oregon and not be in the West. No, I don't like that because it says I'm not in Oregon, right? I can be in California and still be in the West. Ooh, I like that one. So if I'm not in Oregon, then I'm not in the West. Okay, moving on. All right, so let's go down to, see, if I'm not in Oregon, I'm not in the West. We know that's false. Perfect. Okay, so write the contrapositive to this. So we did, the first one was if P then Q. Okay, the second one is if Q then P. The third one here, inverse, is where I negated this. I'm going to put a little tilde. So negation, negation. So if not P, then not Q. And then the last one, the contrapositive, is where I negate and flip. So not Q, then not P. And so let me go all the way back to the top. The P was talking about being in the West, so I need to start with I'm not in the West. So I like this one. I'm not in the West. I'm not in the West. Okay, and then the hypothesis was about being in Oregon, and I want it to be not in Oregon, so I like that one. Okay, determine the truth value of the contrapositive. If I'm not in the West, then I'm not in Oregon. I think that's true. Okay, if I'm not in the West, like if I'm on the East Coast, there's no way I can be in Oregon. So let's go with this. Okay, on to some more mathy stuff. All right, I'm going to fill in some numbers here. It says triangle ACB is 63 degrees. So let me trace ACB. A to C to B, that's that one. So I'm going to put 63 degrees right here. And I need to determine BCD. Okay, well hopefully you notice if this is 90 degrees, I can see that this is a linear pair, so these have to be 90 degrees. And these two also have to add up to 90 degrees. So I'm going to just take a calculator real quick, make sure I don't make any tedious mistakes. And I'll need it later anyways. So 90 minus 63 is 27 degrees. So the correct answer is 27 degrees. All right, moving on. Okay, same problem. ACB, 57. So this guy here is 57. And I'm looking for ACE this time. Ooh, this is a little bit trickier. Let me make sure I did that last one right. What was I looking for? B to C to D. Yep, that's right. Okay, this time I'm looking for angle ACE. A to C to E. Now, I'm going to do the same thing I did last time. I'm going to find this little sliver of an angle here. I'll highlight it in yellow. And since I see these arcs right here, you'll notice one arc and one arc. It means they're congruent. So if I find this angle, I have that one. So let's use our calculator. And we're going to go 90 minus 57. So 33. So this angle here is 33 degrees, which means this angle here is 33 degrees. And then if that's 90 and that's 33, I'll add them together. 90 plus 33 equals 123. So there's my answer, 123 degrees. Okay, next problem. Y is really easy. These are called vertical angles. They're across from each other. They're congruent. So I know Y is 116 degrees. Okay, these two make a linear pair. So they're right next to each other. Okay, they add up to 180 degrees. And I also have another set of vertical angles. If I know that one, I know this one. So let me use my calculator here. So 180 minus 116, and we get 64. So the last two angles are 64 and 64. Okay, on to example number 7 here. Okay, hopefully you notice that it does say up here that these are complementary. Complementary means these add up to 90. So I'm going to make a little algebra equation here. So I'm going to say x plus 17x minus 36 equals 90 degrees. Okay, I can put these x's together, so let's do that. 18x minus 36 equals 90. This is a two-step algebra equation. I go ahead and add 36 to both sides. This goes away. I get 18x equals 126. Final step, divide by 18. Okay, I'm going to use my calculator here. Let me get out of this. Quit, clear. All right, 126 divided by 18 turns out to be a nice clean whole number. So x equals 7. So that is angle 2, 7 degrees. Now I need to plug that back in right here to find angle 1. So what is 17 times 7 minus 36? 17 times 7 minus 36, and I get 83. Now, the reason I like to plug it in, it's kind of like double checking my work. Do these add up to 90? Yes, they do. Okay, so 83. I could have figured that out a lot easier, but again, plug it in, make sure you're doing the math right. Okay, next one, supplementary. This means they add up to 180, and you can see it right here. It's a linear pair. So I'm going to do x plus 14x plus 45 equals 180. Just like the last problem, I can put these together. 15x plus 45 equals 180, and now it's a two-step algebra equation. Minus 45 from both sides. This goes away. 15x. I'm going to go ahead and get my calculator out so I don't make any tedious mistakes. 180 minus 45 is 135. And then we'll go ahead and divide both sides by 15. Divided by 15, and we get 9. So angle 1 is 9 degrees. Now again, I like to plug it back in just to make sure that my math is correct. What would I get if I did 14 times 9 plus 45? And I get 171, which I know these two add up to 180, so it's double checking my work. Okay, on these problems, no matter what type of problem you get, you'll probably get a whole number. If you get a decimal, go back and double check your algebra over there to the right. Okay, on to some proof stuff. Okay, this is called triangle congruence. There are basically 5 ways to prove triangles congruent. One is called side, side, side. These are shortcuts. Side, angle, side. Angle, side, angles. Angle, angle, side. And last but not least, hypotenuse, leg. Any of these shortcuts, instead of identifying all 3 sides and 3 angles, that's a lot of work. If you can prove any of these, it's a shortcut. Now, it's just the way we name things. So I'm going to go in a clockwise or counterclockwise rotation. I notice this is a side, tick marks. This is an angle, and this is a side. So this would be a side, angle, side scenario, going clockwise or counterclockwise. And I get the same thing over here. Okay? This is a side. This is an angle, and this is a side. So these have to be congruent. And it's right here, and I notice the side, angle, side scenario here. Okay, let's go on to the next one. Are they congruent? I'm going to slide this down so we can look at the next problem. And the answer is yes. Look at side, side, side. 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks, 3, 3. Are they congruent? Yes. Why? Because of side, side, side. Okay, I'm going to slide it down. These go quick. Okay, I notice an angle, a side, and another angle. So going clockwise or counterclockwise, this is an angle, a side, and an angle, and it matches up with this one over here. Okay, I might copy this real quick and go to the next page. Okay, now this one's a little bit interesting because right now I only have 2 items on my diagram. But I know if I were to split this into 2 separate triangles here, and what I mean here is I'll actually do it here. So if I have a triangle that looks like this on the left, and I have a triangle that looks like this on the right, hopefully you would notice that this segment in the middle, I guess I should have done those a little bit slower, but here, and then let me draw a totally separate one here. I'll do it in a different color. Okay, if I were to separate these, okay, obviously these 2 center pieces have the same length because they share a common segment, okay? So let's get rid of that and that. And so you'll notice I added 1 tick mark for the left triangle and the right triangle. Now, if I were to go, this one's a little bit weird because I don't get the same thing when I go in both directions. Like that's angle, angle, side, or I could say side, angle, angle, but that's not my list up here. So are they congruent? And the answer is yes. And it's right here. Angle, angle, side. Okay, explain why. Why did I do that? Okay. Oh no, next part. So if the triangles are congruent, can I say that these 2 also have to be congruent? And we have an acronym for that. It's called CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. I'll say it again. Corresponding parts of congruent triangles are congruent. It basically means if I know these 2 triangles are congruent, I could say, well, those angles have to be the same. So I could do 3, 3, 3. And these sides have to be the same. And then these sides have to be the same. I could just basically mark up the rest. And so when I look down here, I notice corresponding parts of congruent triangles are congruent. Okay, I got a little proof here, okay? And I've got drop downs. So step 1, prove the following given the information. So angle, let's see what the given information is first. KWJ, I'm going to highlight KWJ is congruent with HWJ. HWJ. And you notice there's already these tick marks here. Or arcs, excuse me. Arc and arc. I like to stagger mine usually, okay? Now, how do we know that? Well, it's given in the diagram. It's in the given section here. So step 1, I would just say is given. Okay? And I would box this one in because it is given information. Step 2, I notice that it says WJ is perpendicular to KH. So here's WJ, here's KH. It already has a 90-degree symbol here. Okay? And let's see what we got for option 2. Is that anywhere up here? Nope. Okay, so what's our options for option 2? Oh, they give me this 90-degree angle here. It says, and I notice it says, because perpendicular lines for right angles and all right angles are congruent. So one of those angles is WJK and one of them is WJH. Here's WJH, WJK. If this is 90, this would also be 90, right? And so I'm going to go with number 2 here. Angle WJK is congruent with angle WJH. WJ and WJ are congruent. And that's what we had last time. Reflexive, right? Okay. And so this is on line 3. And it's called an included side. So I'll put that right here. Included side. And then 4, reflexive property. Reflexive. Okay, last but not least, just look up here in my picture. Again, I'm looking for side, angle, all of that stuff. I notice as I go around, clockwise or clockwise, that's an angle, that's a side, that's an angle. Okay, same thing on the top. Angle, side, and an angle. So this would be an angle, side, angle scenario. Angle, side, angle. And let's look down here at number 5. And there it is. Okay, same thing. This is called, it's not a 2-column proof. It's not a paragraph proof. It's called a flowchart proof. Okay, so just looking up here, I have some given information. So they tell me that these are given. And I notice, where is it? H to J, that's this one, is congruent with H to G. Boom, already given. Then I notice this. Look at this. Also given, P to J and P to G are congruent. So I'm going to put given in this scenario. Don't need to think about it, already provided. I look down on here, box 1. These will be drop downs in your work. Oh, and then, wait a minute. Aren't these the same segment on both triangles? I could put 3 tick marks here and separate them. And that is PH is congruent to PH. And that would be reflexive. Okay, now you'll notice they already tell me it's side, side, side. I can see it from the diagram. Now you just got to say what triangles are congruent. So let's go down below. And I only have one option here for my triangle. A triangle is congruent to another triangle. This triangle is congruent to this triangle. So anytime you have one of these statements, you got to say something about triangles being congruent. So triangle HJP is congruent with triangle HGP. If I look up at my picture, HJ to P, that's this one. HG to P, let's retrace that. HG to P is this one. Okay, last proof. Okay, SA, so that's this one, and ND are congruent. I see the tick marks. That is given information. Didn't have to do any work there. I'll go down to my drop downs, given. Okay, next one. SD is congruent to NA. SD is congruent to NA. Also given information. Didn't have to do any thinking there. Boom, box 2. Okay, reflexive. We know what reflexive means. It means they share a common side. 1, 2, 3. I would say AD is congruent with AD. And if I look at my options, oh, they actually split it up and did it the proper order. So I'll say DA. I'll do it right. Okay, last but not least, that means the triangles are congruent. Why? We'll look up at this scenario. I notice side, side, side. So this would be a side, side, side scenario. S, S, S. Let's go down to my drop-down menu. Boom. And then last but not least. Okay, then if the triangles are congruent, wouldn't that mean I could go up here and say, hey, these angles also have to be congruent? Boom, and boom. And that's because of corresponding parts of congruent triangles are congruent. And the acronym here we use is CPCTC. And down here, corresponding parts of congruent triangles are congruent. And we are done.